going to explain the fraud detection in financial transaction. These are my team members. Now I'm going to explain about the abstract. Detecting fraudulent financial transaction using machine learning ML models. Key techniques they are used are anomaly detection, identifying outliers in the transaction data, classification models using supervised learning techniques like random forest and SVM and neural networks, feature engineering, extracting the key transaction attributes to improve the model performance, and expected impact here a faster fraud detection, reduced financial losses for banks and users, enhanced security in digital transactions. Next, literature traditional methods, rule-based detection, predefined fraud rules, statistical methods, outlier detection, probability-based models, challenges, high false positive static rules and manual intervention, machine learning-based solutions, supervised learning, decision trees, random forest, SVM, neural networks, and unsupervised learning, clustering, isolation forest, deep learning approaches like CNNs for sequential transactional analysis. Recent research in insights advanced in AI and big data analytics, hybrid models combined based on ML techniques. Next, existing system. Traditional fraud detection techniques, a rule-based system with predefined fraud rules, manual verification by analysts. Here the challenges are high false positive rate, slow response time, scalability issues, and constantly evolve new techniques, making static rules and ineffective. Next, Kushala.
Now I am going to explain the problem definition. Increase in digital transaction leads to rising of financial fraud. Cybercrimes constantly evolve their statics. Why traditional method fails? Static rules cannot adapt to a new fraud patterns. Too many alerts make it hard to detect the real fraud. Need for an ML-based system. Automatically learns a new fraud patterns, processes and real-time data efficiency. Now I am going to explain the proposed system. ML-based fraud detection approach. Supervised learning models like train on labeled fraud datasets. Unsupervised learning models detect the anomalies in transactions. Deep learning used for complex fraud patterns. Techniques used in this project are random forest and RGBoost, high accuracy classification models. Neural networks are detect the subtitle fraud patterns, then real-time monitoring, in immediate fraud detection and alerts. Now I'm going to explain the hardware requirements of this project. Minimum hardware required of processor is Intel Core i5 or i7 or AMD Ryzen equivalent. RAM should be like 8 GB, recommended to 16 GB for deep learning. Storage should be 256 GB SSD, recommended up to a 512 GB for large datasets needed. GPU like NVIDIA GTX 1050 or better for deep learning models. Next, I'll explain my friend Srishti.
Next, I am going to explain software requirements. Programming language is Python. Libraries used are Transform, Flow, Pandas, and NumPy. Database are MySQL, MongoDB for transaction storage. Development tools, VS Code, etc. Next, I am going to tell about the advantage of proposed system. Automated fraud detection. It reduces the manual workload, real-time analysis, immediate fraud identification and blocking, high accuracy. ML models improve fraud detection over the time, reduce financial losses. It protects customers and the banks. Scalability. It handles large volumes of transaction data efficiency. Next, I am going to explain systems testing. Functional testing ensures all fraud detection features work correctly. Security testing checks vulnerabilities in fraud detection algorithms, preventing model attacks. Scalability testing evaluating system performance on large datasets. Data quality testing validating transaction data integrity. Next will be explained by Priyanka.
On
I'm
your mic.
explaining about the performance testing. Key performance matrix, precision and recall, measures fraud detection accuracy, false positive rate and false negative rate. False positive rate, avoid blocking legitimate transactions. False negative rate, minimize the undetected fraud cases. Response time evolution, ensure real-time fraud detection. Comparison with traditional methods, demonstrating ML super. Next, unit testing and integration testing. Unit testing, data pre-processing modules, feature selection algorithms, model training and validation. Next, integration testing, database and ML model, interaction, fraud alert system with banking APIs, deployment testing and real-time transaction. Next, reference. Research paper, Machine Learning for Fraud Detection IEEE, Anomaly Detection in Finance Transaction, Journal of AI Research, books and online courses, Data Science for Fraud Detection, Deep Learning Application in Finance, online source,